We imagine living on Mars for decades. Books, movies, even billionaires have painted visions of humans building cities on the red planet, walking under terraformed skies, maybe even planting trees in Martian soil. But here is the big question. Could we really do it? Could we actually turn a frozen, airless world into a second Earth? Terraforming Mars isn't just a sci-fi fantasy anymore. It's a scientific challenge and one of the most extreme projects humanity could ever attempt. The planet is cold, dry, and bathed in radiation. Its atmosphere is 100 times thinner than Earth's and composed mostly of carbon dioxide. There is no breathable air, no liquid water on the surface, and definitely no forests or rivers, yet. But it's also the most promising candidate in the solar system. Mars has seasons, it has water locked in ice, it has gravity about 30% of Earth's, which is enough to possibly support long-term human habitation. And thanks to rovers and satellites, we know more about it than any other world beside our own. So if we were to try, where would we even start? Before we dive into the how, let's talk about the why. Why Mars? Why terraform any planet at all? The short answer is survival. Earth won't last forever. Whether it's climate change, overpopulation, asteroid impact, or a distant supernova, every civilization needs a backup plan. And right now, Mars is our best option. It's not easy, but compared to the Moon, Venus, or the outer planets, Mars is practically friendly. Let's break it down. Mars is the closest planet that shares key features with Earth. It has a 24.6-hour day, polar ice caps, seasons, and the possibility of vast underground water reserves. Its gravity, though weaker, is strong enough to potentially support human physiology long-term, unlike the Moon, which has only 1/6 of Earth's gravity, and its surface area is comparable to all of Earth's dry land combined. Most importantly, Mars has potential. It's not completely dead. Frozen carbon dioxide and water mean we might be able to unlock the atmosphere. There are signs that Mars may have once had rivers, lakes, even an ocean. If it had those before, maybe we can bring them back. So, why terraform? Because colonizing Mars with domes and pressure suits might be enough for a foothold. But terraforming it into a world where humans can breathe the air, grow food outdoors, and live freely, that's something else entirely. It's not just about leaving Earth, it's about making sure human life has a future beyond it. So what's the first and most essential step in terraforming Mars? Creating an atmosphere. Right now, Mars has an atmosphere, barely. It's about 1% as dense as Earth's, and it's made almost entirely out of carbon dioxide. There's no breathable oxygen, and the pressure is so low that if you stood on the surface without a suit, your blood would literally start to boil. To make Mars habitable, we'd need to thicken the atmosphere dramatically. Not only to hold in heat, but also to provide pressure and eventually support oxygen and liquid water. So, how do we do that? One idea is to release CO2 already trapped in Mars itself. There's frozen carbon dioxide at the poles and possibly locked in the soil. The controversial proposal? Nuke the poles. Elon Musk famously suggested to detonating nuclear weapons above the polar ice caps to vaporize them, releasing CO2 and kickstarting a greenhouse effect. While dramatic, this method faces serious feasibility, safety, and ethical challenges. A more practical idea: build massive greenhouse gas factories. These would release super potent gases like perfluorocarbons, thousands of times more effective at trapping heat than CO2. Over decades or centuries, they could warm the planet and slowly thicken the air. Other methods include giant orbital mirrors to reflect sunlight onto the surface, or redirecting asteroids rich in gases to crash into Mars, releasing their contents into the air. The goal is simple, but monumental. Raise atmospheric pressure to a level where water can exist as a liquid, and the air is thick enough to start holding heat. This step alone could take centuries, but without it, every other stage is impossible. Terraforming Mars starts with changing its sky. Even if we succeed in thickening Mars's atmosphere, there is another massive problem. It's still way too cold. The average surface temperature on Mars is about -63 degrees Celsius, or -81 degrees Fahrenheit. At the equator during the warmest day, it may barely rise above the freezing. But overall, it's an icy, bone-dry desert. Without serious heating, liquid water couldn't survive, and neither could we. So, the next critical phase of terraforming is warming the planet. Some of this might happen naturally as the atmosphere thickens. A denser atmosphere helps trap more heat from the sun, kickstarting a greenhouse effect. But on Mars, that effect would be weak, so we would need to give it a push. One leading idea is to produce powerful greenhouse gases like perfluorocarbons. These synthetic gases don't occur naturally but could be manufactured by automated factories on the Martian surface. They are incredibly efficient at trapping heat, thousands of times more potent than CO2. The problem? We need millions of tons of it, sustained over decades. Another concept involves orbital mirrors, giant reflective structures in space designed to redirect sunlight onto Mars's surface, especially its poles. That concentrated heat could warm vast regions and even help release trapped CO2 and water. There is also the idea of dusting the poles with dark material to reduce their reflectivity. That would cause more solar energy to be absorbed rather than bounced back into space, speeding up the melting of ice and triggering further greenhouse warming. Each of these strategies come with enormous technological and ethical struggles. But the objective is clear: raise Mars's temperature enough to allow stable water, breathable air, and maybe even outdoor ecosystems. We are not trying to make Mars comfortable yet, we are trying to make it survivable. Thickening the atmosphere and raising the temperature are huge steps, but they only create the conditions for life, not life itself. To truly make Mars habitable, we need to add two essentials: oxygen and liquid water. Let's start with water. Mars has no oceans or rivers on the surface today, but it's not completely dry. There are vast reserves of frozen water locked in the polar ice caps and potentially in underground aquifers. Some evidence even suggests there could be salty liquid brines under the surface. As the planet warms, the ice could start to melt, forming temporary lakes and perhaps shallow seas. But to truly hydrate Mars, we might need to import water, possibly by redirecting icy asteroids or comets to crash land in targeted regions, delivering massive volumes of H2O. Then comes the real challenge: oxygen. Mars's current atmosphere is over 95% carbon dioxide. There's almost no oxygen and definitely not enough to breathe. So, how do we change that? One method is to use photosynthetic organisms like algae, cyanobacteria, or even engineered plants. These could slowly convert CO2 into oxygen just like Earth's early life did billions of years ago. But this process would be painfully slow on a planetary scale. A faster, though more energy-intensive option is electrolysis, splitting water into hydrogen and oxygen using electricity, ideally powered by solar arrays or nuclear reactors. However, this requires infrastructure, stability, and immense resources. Even if we succeeded in adding oxygen, the atmosphere must be thick enough to hold it in. Otherwise, Mars's weak gravity and lack of magnetic field could allow gases to escape into space over time. Still, without oxygen and water, humans can't live freely on Mars. This is the turning point, where Mars stops being a hostile rock and starts becoming a world we could truly call home. Once you've got a thicker atmosphere, rising temperatures, liquid water, and maybe even trace amounts of oxygen, it's time for the next giant leap: growing life. But on a planet that's been dead for billions of years, this isn't as simple as planting seeds. Mars has no soil rich in organic matter. Its surface is full of toxic perchlorates, it's bathed in radiation, and it's missing the vast web of bacteria, fungi, and microfauna that make Earth's ecosystem work. So, how do you start life from scratch? The answer is you build it from the bottom up. Terraforming Mars would require carefully introducing microbial life first, extremophiles that can survive cold, low pressure, and high radiation. These could begin breaking down minerals, processing perchlorates, and enriching the regolith, Mars's soil, with organic material. Next might come something like engineered algae, capable of photosynthesis and oxygen production in thin atmospheres. These organisms could thrive in shallow ponds, sealed greenhouses, or even open-air environments once conditions improve. Only after microbial ecosystems are stable could we begin to think about introducing plants, and not just any plant. These would need to be genetically modified to withstand Martian conditions, likely starting in enclosed biodomes before expanding into open environments centuries later. This stage would be slow, possibly taking hundreds or even thousands of years. But it's essential. Growing life isn't just about making Mars green, it's about creating a self-sustaining biosphere. One that recycles gases, supports food chains, and stabilizes the environment without constant human intervention. This is the moment where Mars begins to shift from a terraformed world to a living one. But for humans to thrive there long term, we'll need more than microbes and moss. We'll need infrastructure, protection, and cities. Terraforming Mars doesn't end with changing the environment, it culminates with one of the boldest visions humanity has ever imagined: building cities on another world. Even with a breathable atmosphere and liquid water, Mars would remain a hostile place for a long time. Radiation from the sun and cosmic rays would still pose a major threat due to Mars's lack of strong magnetic field. Temperatures would fluctuate wildly, and massive dust storms, some of which can cover the entire planet, could last for weeks. So how do we build homes, communities, and cities in this kind of environment? At first, we wouldn't live above ground at all. Underground bases or habitats built into lava tubes would provide protection from radiation, temperature swings, and micrometeorites. As the atmosphere thickens and conditions stabilize, we could begin constructing pressurized domes, likely made from advanced composites or even local materials like Martian regolith. These early colonies would rely on artificial ecosystems, controlled farming modules, and constant life support. Eventually, if terraforming efforts succeed, we could envision open-air cities, settlements without pressure suits, where humans could walk under engineered skies, grow food outdoors, and build infrastructure that feels more like home than a bunker. These cities wouldn't just be functional, they would be symbolic, proof that a once-dead planet could be made livable and beautiful. Imagine lakes where there was once ice, greenhouses glowing under twin moons, and children born on Mars knowing only a red world slowly turning blue. It's not just science fiction, it's a future worth building, if we have time, the technology, and the will. But all of it hinges on one thing: whether we should. Terraforming Mars might sound like the ultimate human achievement, but it's not without enormous risks, practical hurdles, and deeply complex ethical questions. First, the technical challenges are staggering. We are talking about altering an entire planet's atmosphere, climate, and ecosystem, something no civilization has ever done, not even on Earth. The scale of energy, resources, and time required would span centuries, if not millennia. There are no guarantees that any of it would work, and we could pour our generations of effort into a plan that ultimately fails. Then there is the cost. Terraforming wouldn't just be expensive. It would be the most expensive endeavor in human history. Is it worth investing trillions into transforming Mars when Earth itself is facing environmental collapse? Could we end up abandoning our home planet in pursuit of a shiny red backup? Now consider the ethical questions. Mars might appear dead, but what if it's not? There is still a chance microbial life exists beneath its surface, and terraforming could wipe it out before we truly understand it. Do we have the right to remake an entire planet in our image? Would we be colonizing or contaminating? There is also the philosophical dilemma. If we terraform Mars, are we solving our problems or just exporting them? If humanity couldn't take care of Earth, why should we be trusted with another world? These aren't questions with easy answers, but they are questions we have to ask. Because terraforming isn't just about science and technology. It's about who we are and what kind of species we want to be. And in the end, Mars may offer us more than just a second home. It may hold up a mirror to our future. So, is terraforming Mars just a dream? Or is it our destiny? The truth is, it's both. Right now, the idea of transforming an entire planet, raising its temperature, building atmosphere, seeding it with life, and turning it into a second Earth feels like science fiction. And to be honest, it is, for now. But every great leap in human history started as fiction. We imagined flying before we built airplanes. We dreamed of stars before we reached the moon. Terraforming Mars isn't impossible, it's just incredibly hard, a challenge on a scale we've never attempted before. And yet, the pieces are already forming. We have rovers mapping the terrain, orbiters studying the atmosphere, and private companies developing reusable rockets that could one day bring cargo or people to the Red Planet. Chang'e missions, Artemis, Starship, it's all part of a very real trajectory. Still, the question isn't just whether we can terraform Mars, it's whether we should. Because this is more than just a science project, it's a choice about what kind of civilization we want to be. Will we become planetary caretakers, spreading life to lifeless worlds? Or cosmic colonizers repeating mistakes across the stars? Mars may be waiting, but the future it holds depends entirely on the decisions we make now, on Earth. And maybe that's the most powerful part of this dream, that it pushes us to become the kind of species that's worthy of another world. Thank you for watching, keep looking up.